Good morning, students. Today we are going to learn the chapter number 10 in standard 10. So in this chapter we are learn about the various concept of the light. Okay, so the chapter name is light. Now what is the definition of light? So light is a ray which enable to see us. Okay, light is a form of energy which enable to see us. Means what is happen? Whenever we can see any object, whenever we are going to see any kind of object, so there is some sensitivity in our eyes. Okay, sensitivity. So light rays are those rays which produces sensitivity in our eyes, produces sensitivity in our eyes. So these waves are called, these energy particles are called light. Okay, understood? Now, so there are some various properties of the light. Okay, as you know, in a vacuum, there is no medium. Okay, so in a vacuum there is no medium. At that medium, the light ray will travel at the speed of 3 into 10 raised to 8 meter per second. Okay, so in vacuum there is no medium. The light ray will travel at the speed of 3 into 10 raised to 8 meter per second. Fine. So the first property has been done. Now the light ray are those rays which can able to travel in vacuum also. So these are called electromagnetic waves. Okay, in the standard 9th we had learned about the sound waves. Okay, so sound waves are what? So they are the mechanical waves. They are the mechanical waves because the sound waves required a medium to transport, but in case of light, the light will not require any medium to transport. So that's why it is called electromagnetic waves. Why? Because it does not require a medium to travel. Fine. And the second point is the light is also travel in the straight line. Okay. Now the third point, the light having dual nature. Why dual nature? Because in earlier centuries many scientists are going to explain the forms of light. So they predict the light, the first form of the light is in wave form, and the second form of the light is in particle form. Okay, so light can travel in a particle form also, and light can travel in a wave form also. Okay, so the detailed concept for this two concept will be discussed in the higher studies in 11th science and 12th science. Okay, now this point has no significance, and this point is already we had discussed, because in the vacuum the light will travel at the speed of 3 into 10 raised to 8 meter per second. Okay, now so learn about the case. Suppose this is a surface, this is a colored surface, colored, or I had polished here. Okay, so whenever a light ray will strike toward this surface, it will get back to the same direction. Why? Because as usual we had make this surface non-transparent. What? Non-transparent. Okay, so this surface is non-transparent. That's why whenever the light ray falling on the surface, it will get reflected in the opposite direction. So this phenomenon is called reflection. What? This phenomenon is called reflection of light. Fine. And the second phenomena, for example, we had a glass filled with the water. Okay, suppose I am going to insert a pencil over there. So what you will see, the pencil is bent somewhat. Okay, so as you already are familiar about this example, whenever we dip a pencil in the glass, it will get, see here the example is given, it will bend. Okay, so this phenomenon is called refraction. What is refraction? Okay, so when the light falls on a surface, three things are happen. First is reflection. So whenever the light strikes and back to the surface, this is called reflection due to the polished surface. Okay, and the second phenomenon is refraction, and third is absorption. Okay, now let's talk about the reflection. So bouncing back of light when strike with the polished surface, as I already told you. So whenever the light will strike to the polished surface, this is the polish, this is I am doing the polish. So whenever the light strike with the polished surface, it will get reflected in the opposite direction. So this phenomena is called reflection. What? This phenomena is called reflection. So in this case what happened? The light ray get bounced back. Okay, so the bouncing back of the light rays when struck to the polished surface is called reflection of light. Okay, Now I'm going to zoom this diagram. Okay, so let us understand better. Fine. See, this diagram is given. Now listen. This is the polished surface. Okay, here some polishes are made. Clear? Now the light ray which incident on a surface, this is called incident ray. Why incident ray? Because the light ray is going to incident on a surface. Clear? Now the light ray which get back after striking the surface, this surface is called refracted ray. What? This surface is called refracted ray. Okay. Now this point at which the incident ray and reflected ray are meeting, this is called point of interference. This is called point of interference. Okay. Now from that point of interference, a straight line which is passes, this is called normal. Okay. From the point, see, this is the point of interference. So from the point of interference, the perpendicular line which passes, that is called normal of the line. Clear? Now see, the incident ray is making an angle with the normal. Okay, this angle is going to happen. So this is called angle of incidence. Okay, so the angle between incident ray and normal is called angle of incident. Clear? Now the same definition for the angle of refraction. So the refracted ray and the normal. So the angle between refracted ray and normal, suppose that is theta r. So that is called angle of refraction. Okay, understood? So now here you have to learn some terminology. The first terminology is incident ray. So the light ray which falling on the non-transparent surface. Again guys, you have to remember this surface is non-transparent. So the light ray which falling on the non-transparent surface, that is called incident ray. Understood? Now the light ray which bounce back or which get reflected from the surface, that is called reflected ray. Clear? Okay. Now the first thing is done, second thing is done, third thing is what? This. So this is called point of interference, where the incident ray and reflected ray are meet. Okay, they are going to meet. Okay. Now the fourth point is what? Normal. So the line, perpendicular line passes through the point of interference, it is called a normal. Okay, the perpendicular line which passes through the point of interference, that is called normal. Now the angle between incident ray and the normal, this angle represent theta I, means theta incident. So that is called angle of incidence. Clear? Now the reflected ray which makes an angle with the normal, that angle is called theta r, angle of reflection, because it is made with the reflected ray. Clear? So there are some two basic laws to understand the laws of reflection. Okay, so you have to go through the laws of reflection. So the first law will stand, law of reflection. This is the 2 marks most MP topic in the examinations. Okay, now understood. See, in the first point this mentioned that the theta I over here and the theta r over here having the same value. Clear? So what is the conclusion? The theta I, which is called angle of incidence, and the theta r, which is called angle of reflection, having the same value. So the first point stands for the angle of incidence is equal to the angle of reflection, means this angle and this angle are equal. Suppose this angle is represented by theta r and this angle is represented by theta I. Understood? So the angle of incident and the angle of reflection having the equal value, having the same magnitude. Clear? So this is the very much first law of angle of reflection. Now the second law states that the incident ray, the reflected ray, the normal, all are in same plane. See, the incident ray, the reflected ray and the normal at the point of incidence all lie in same plane. Okay, all lie in same plane, means all the points, see this point and this point, all points are lying on the above the surface. So all the points are in same plane. Okay, so what is the first law? The incident angle and the refracted angle having the same value, and the incident ray, reflected ray and the normal are in the same plane. Okay, so this is called the laws of reflection. Okay guys.